Hi, hello dear students. Welcome to our channel Maths with Panindra. In this video, we are going to discuss about mathematical induction, which is a very important topic in intermediate. From this topic, we will expect one long answer type question. So, which contains 7 marks. So, either it is in TS or AP. One damn sure question from mathematical induction. So, I am going to make two videos in mathematical induction. One is based on series, one is based on divisibility problems. So two playlists I am going to provide for you. Let us have a discussion the concept of mathematical induction. So in this mathematical induction, how to prove the given statement by using mathematical induction. Simple way I am going to explain the procedure and all. So in this mathematical induction, for the given statement, we need to take three important steps. Steps to prove a statement using the principle of mathematical induction. The first step is basis of induction. So in the basis of induction, we have to prove the given statement true for n is equal to 1. Suppose if you are assuming the statement is s of n, you prove the statement true for n is equal to 1, that is s of 1 is true. If you are assuming that is p of n, p of 1 is equal to true, p of 1 is true, you have to prove it. That is about basis of induction step. Come to the second one, inductive hypothesis. What is meant by inductive hypothesis? For the given statement, for k is greater than or equal to 1, assume that p of k is true. So wherever nth term is there in the statement, replace with k and write kth term, and it is assume that the statement is true for n is equal to k. That is called hypothesis step, inductive hypothesis. In the third one, inductive step. What is the difference between inductive hypothesis and inductive step? Inductive hypothesis, we are assuming that statement is true. In the inductive step, we are going to prove the given statement. Here already we assume that it is true for n is equal to k, no? In this third step, inductive step, we are going to prove the given statement true for n is equal to k plus 1. That means p of k plus 1 or s of k plus 1 is true. Show that p of k plus 1 is true on the basis of the inductive hypothesis. Here we assume that it is true for n is equal to k. Here we are going to prove n is equal to k plus 1. So what type of questions are there in this? Two types of questions are there. One is based on series type problems. Series problems. Another one is divisibility problems. Divisibility. So first we are going to discuss about the series problems. In one video, series problems I am going to make. In another video, I am going to make divisibility problems. Let us have a discussion, dear students. The first question, dear students. Show that for n belongs to capital N, a plus d, a plus 2d plus and so on up to n terms, n by 2 equal to 2a plus n minus 1 into d by using mathematical induction. So for first mathematical induction, whenever the statement is given like this, nth term is there or not, first you verify. If not there, calculate the nth term of the given series. Then you can proceed by taking as s of n or p of n. So here a plus d, a plus 2d, if you observe that, which are in absolutely AP, arithmetic progression. So nth term of arithmetic progression is what? Tn equal to, we know that a plus n minus 1 into d, no? So nth term of AP. So in place of up to n terms, you replace with Tn. So therefore the statement will come, let the statement be s of n equal to a plus d plus a plus 2d and so on. The nth term of the AP, so A plus n minus 1 into D is equal to n by 2 into 2A plus n minus 1 into D. This is S of n statement, dear students. So in the given series, they did not give an nth term. We wrote nth term and we have taken as S of n. This is the first step. Basic one. Next, in the step 1, what we are going to do that? In the step 1, we have to prove that the given statement S of n or P of n, according to this question, we are assuming that S of n is true for n is equal to 1. To prove that S of n is true for n equal to 1. This is step 1. In this, what we are going to do is, in statement S of n, this part is LHS, this part is RHS. The nth term, whatever we got it, no, that is LHS of the statement, LHS. So, nth term of the series will be, no, A plus n minus 1 into D. N is equal to 1, substitute in this. So, A plus 1 minus 1 into D, so which is equal to A. 1 minus 1 is 0. A plus 0 is A. Next, RHS value in the series. This is RHS value, dear students. N by 2, 2A plus n minus 1 into D. So here, A plus n minus 1 and n is equal to 1. We are substituting now here. So which is equal to n value 1 by 2 into 2A plus 1 minus 1 into D. This value is 0. 1 by 2 into 2A, which is equal to A. Whenever LHS and RHS of the given series S of n are equal, the given statement is true for n is equal to 1. Therefore, LHS equal to RHS, the given statement, therefore, S of n is true for n is equal to 1. So we prove that the given statement is true for n is equal to 1. Come to the step 2. In the step 2, what we are doing is, assume that the given statement is true for n is equal to k. That only you should write it the matter. Assume that the given statement, the S of n, is true for n is equal to k. That means in the given series, wherever n is there, replace with k. So therefore, S of k I am writing, dear students. S of k equal to A plus D plus A plus 2D plus and so on, A plus k minus 1 into D is equal to k by 2, 2A plus k minus 1 into D. So this is about wherever n is there, it satisfies with k, it is true for n is equal to k. Assume that S of n is true for n is equal to k means in the statement wherever n is there, replace with k. When you are moving to the third step, in the third step what we are doing, we have to prove n is equal to k plus 1. So the third step, before writing third step, we need to calculate k plus 1th term, dear students here. What is the kth term in this? The kth term is this one, A plus k minus 1 into D. Are you able to see? 1 minute. Yeah, absolutely. You are able to see. This is the kth term. To prove the k plus 1th term, here I want k plus 1th term. So wherever k is there, replace with k plus 1. So k plus 1th term equal to a plus k plus 1 minus 1 into d. Plus 1 minus 1 get cancelled, which is equal to a plus kd. You remember your students. So this is the required one. We have taken the help of kth term to prove the s of n plus, that means third step. We need to take up help with the a plus kd. So second step completed. In the third step, we are going to write step 3. In step 3, we have to prove s of n for n equal to k plus 1. So whenever you are going to prove the given statement s of n for n is equal to k plus 1, adding k plus 1th term on both sides to s of k. For this statement, is there no s of k statement? This is s of k. For this, we have to add both sides the k plus 1th term. What we got the k plus 1th term? This is the turning step, dear students. You remember. So this value we are going to add. So first you write it, s of k plus 1 equal to, whenever you are adding k plus 1th term, s of n, s of k will become s of k plus 1. So a plus b plus and so on. K plus 1th term is what? Kth term is a into k minus 1 into d, plus we are adding a plus kd. So which is equal to this side, RHS side, k by 2, 2a plus k minus 1 into d. We are adding how much? A plus kd we are adding. So take LCM. 2 is the LCM. So k into 2a plus k minus 1 into d plus 2 times of this one, 2 into a plus kd. So now simplify, k by 2, 2a plus kd minus d plus 2a plus 2kd, which is equal to k by 2, 2a plus kd plus 2kd. So total kd plus 2kd, 3kd will come. Next, we need to minus, here also 2a plus 2a is 4a. 3kd minus d. Our aim is, in this result, n by 2 into 2a plus n minus 1 into d is there, no? Wherever n is there, k plus 1 I want. So k plus 1 I want. So how to get it? K plus 1. We are adding a plus kd on both sides. We are adding k plus kd. So k by 2 into 2a into k minus 1 into d plus a plus kd. So 2 also we multiplied there. So the rest of the terms, k into 2a. So this k will come for this also, dear students. K into 2k. So take LCM 2, k into 2a plus kd minus kd plus 2a plus 2kd. Now we will simplify. Dear students, previously I have taken k by 2, that is not correct one. This is the right way. So 2ka plus k into k minus 1 into d plus 2a plus 2kd by 2. So here 2ka plus k square d minus kd plus 2a plus 2kd by 2. So 2ka 2kd minus kd plus kd. So k square d plus kd plus 2a by 2. Now what I am going to do is, from these two 2a I am taking common, from these two kd I am taking common. So 2a if you take out common, k plus 1 will come. From these two kd if you take out common, k plus 1 will come. Did you understand, dear students? By 2. So k plus 1 take out. So k plus 1 by 2 into 2a plus kd. Almost we done this answer with RHS. Are you able to see? Yes, you are absolutely able to see. So after this step, we are going to prove that wherever n is there in this RHS, replace with k plus 1 now. N by 2. N is equal to k plus 1, we got it. But here, k plus 1 minus 1 I want. Can you write this step as k plus 1 by 2, 2a plus kd can be written as k plus 1 minus 1 into d. Is it in the form of n by 2 into 2a plus n minus 1 into d? So, conclusion step. Therefore, it is true for n is equal to k plus 1. Therefore, s of k plus 1 is true. After that, by principle of mathematical induction, the given statement s of n is true for n belongs to capital N. This is the way you can do, dear students. According to my convenience, board convenience, I am doing here. We'll move on to this is AP series, no? Geometrical series also we will discuss the question. Yeah, dear students, this is geometrical geometric series. Show that for n belongs to n, a plus ar square plus and so on up to n terms, a into r power n minus 1 by r minus 1. So in previous question we are continuing now. So same steps are there to reduce the explanation time. I have utilizing in this way. S of n equal to a plus ar square plus and so on, the nth term of the geometrical progression. So here I am writing Tn equal to a r power n minus 1. So in place of up to n terms, you replace with a r power n minus 1 is equal to a into r power n minus 1 divided by r minus 1, where r is not equal to 1. We provided that. This is the statement s of n. In this, what is LHS? In the step 1, to prove that s of n is true for n is equal to 1, this is LHS, this is RHS. Consider LHS. A r power n minus 1. So n is equal to 1, we are substituting in this. A into r power 1 minus 1. So a into r power 0. A into anything power 0 is 1. So ultimately the value is a. RHS value a into r power n minus 1 divided by r minus 1. So a into r power n value 1 minus 1 divided by r minus 1. So r minus 1 get cancelled, which is equal to a. So whenever LHS equal to RHS, s of n is true for n is equal to 1. That means s of 1 is true. Therefore, s of 1 is true. So first step completed in this question. Now come to the second step. What is the second step? Assume that s of n is true for n is equal to k. So s of k equal to wherever in the series n is there, replace with k. So s of k equal to a plus ar square plus and so on, a r power k minus 1 is equal to a r power k minus 1 divided by r minus 1, where r is not equal to 1. After that, the kth term is this one, a r power k minus 1. K plus 1th term means wherever k is there, replace with k plus 1 only. So a r power k plus 1 minus 1. Plus 1 minus 1 cancel. Therefore, you will get a power a into r power k. This term we are going to add for the step 3. So in step 3, we have to prove the given statement S of n for n is equal to k plus 1. Here, not able to see, I think, for the bulb effect. So I am explaining here. We have to prove that S of n is true for n is equal to k plus 1. Adding k plus 1th term on both sides to S of k. So what is S of k? This is S of k value. For this we are adding on both sides the k plus 1th term, what we got it here. A r plus and so on. A r power k minus 1. What is k plus 1th term? A r power k, that we are adding. So already a into r power k minus 1 is there by r minus 1 plus a r power k we are adding. So separately RHS only we will take it. A into r power k minus 1 divided by r minus 1 plus a r power k. Take LCM r minus 1. So a into r power k minus 1 plus a r power k into r minus 1. I hope understand students by taking LCM here. A r power k minus a plus a r power k into r minus a r power k divided by r minus 1 minus a r power k plus a r power k get cancelled. Next, from these two, a take common, r power k into r minus 1 divided by r minus 1. Base are equal, both should be added. So a into r power k plus 1 minus 1 divided by r minus 1, provided that r is not equal to 1. So observe carefully, dear students. In place of n, I want k plus 1 now. So is it the same? A into r power k plus 1 minus 1 by r minus 1. Therefore, the statement is true for n is equal to k plus 1. Therefore, S of k plus 1 is true. Directly we can write it, dear students. After reaching of this step, S of k plus 1 is true. Later, the last conclusion step. By principle of mathematical induction, the given statement S of n is true for all n belongs to n. This is the way you can give the answer. We'll move on to the another questions, and I said I will give you the two playlists, but I want to make different questions in the playlist. Sometimes I'll explain the tab also based on that situation. I hope you understand. If you like this video, please share to your friends and relatives. Thank you all.